I just learned about
About what?
I watched the video.
Yeah, I got 2 degrees blast right in the eye.
Yeah, but you did it on the test.
Yeah, but I didn't know it then.
Oh,
So it's
you did it.
just,
How could you? Oh. Well, that's really weird because you wrote one. All right, here we go. All right, turn around, get your homework out. All right, wait for everybody to quiet down so we get going here. You should not be progress today. Tomorrow you will. Randy, was that a question?
No, I didn't.
All right, hush please so we can get going here.
Because he just played.
It's not mine.
All right, questions. What do we got? Haley, question? But I need everyone else to hush so we can do this. Let's take a look at number 14. Number 14. All right, let's take a look at number 14. Number 14 says to solve either by addition or subtraction. The rules for addition and subtraction, you add when the signs are opposite, you subtract when the signs are the same. So number 14, read 14.
Negative 28G plus 15.
Plus 15H equals negative 18. Second one.
Negative 28G minus 48.
Hey,
Minus 30.
hey guys.
Yeah.
Zip it now. Minus 40, 40 equals. Okay, when I said zip it, literally I want no sounds. Okay, stop. Okay, Kaylee, this is your question. The rules are you add if the signs are opposite, you subtract if the signs are the same. So what are we doing? Add or subtracting here? Because the signs are opposite, right? Okay, that's what you got to be able to do all by yourself. Okay, you got to look at it, you see which one matches. Oh, I got 28, 28. Then you look at the signs. If they're the same, you subtract. If they're different, then you add. So here we go. It's a subtraction one because the signs are literally the same. If the signs are literally the same, you subtract. When you subtract, it means you go to the second equation and you do what?
You flip it.
We flip all the signs. Minuses become plus. Hey, they're all minuses, so they're all pluses. Okay. Now we add. Okay. That would go away. A positive 40 and a positive 15 would be 55H. And a positive and negative means we're subtracting. What's that give me? 11? Is that right? Boy, that's an ugly answer. So we get H is equal to 1155, which would be 1/5. Okay. A lot of times you will get from. By the way, you do this because it's not a lattice point. Okay, so it's not surprising we got an ugly answer. Boy, there's no friendly or friendly thing. We got to take 1/5, and that's what H is. We got to throw into one of these equations. Doesn't really matter which one. They're all ugly. So this one, we changed them all positive so we can do that one. So we'll do that one. So we get 28G plus 40 times H. We know H is 1/5, so times. And that's supposed to equal a positive 29. Well, the only bright spot here is that we're going to get rid of the fraction in this one step. 40 divided by 5 is 8, right? 8, right? Okay, so we get 28G. Plus 8 is equal to 29. Subtract 8 from both sides and we get So we get 28G is equal to 21. Therefore, G is equal to 21 over 28, which reduces, what, 3 goes? No, 7 goes into both. So we get 1/4, 3/4. I can't do math. So we got it. Let's see. We put it alphabetical since it's an H and a G. So we got 1/5, 3/4. Yes, right answer. Okay. Oh, that was ugly. Ugly, ugly, ugly.
You like numbers, say, man. You like equations, yeah.
Truth hurts sometimes. All right.
It really does.
Ready? Let's grade. All right. Number 2. By the way, you're at home, you're doing this. If you ever want to check system equations and they're not of the form of y equals mx plus b, if they are, use your graphing calculator. But if they're not, just go on Desmos. You can type it in exactly the way it appears. To include not x's, not y's. It will take h's and g's as well too. It will put it in the form of I got to verify that. I'm pretty sure you can put a's and b's, and it will put it in the form of x is the whatever alphabetically number comes. I got to confirm that. We'll do that in the class, but I think it will do that. If not, then you just change a to x and b to y, and you're fine. Number 2 is 6 - 1. Number 4, 37/3 -4. Number 6, 7 - 2. Number 8, 5 - 1. Rylan, stop what you're doing. Sit there and shame. All right. Number 10, -10, 3. Number 12, 4/9, -3/5. We just did 14, 3/4, 1/5. 16, 300, 300. And the last one, number 18, -20, -18. Why is there a picture of a cat and a dog and chickens? That seems random.
Look at happy.
All right. We are going to finish. I'll collect. Oh, just pass those to the left, please. Pass those to the left. No. Let's see. All right, calendar. We got nothing except for today's class. Today we have some new stuff. Let me talk, please. We have new stuff today, but it's a continuation of elimination. Tomorrow will be a practice day. It'll still be mostly on elimination, but I'll throw in, 2 graphing and 2 substitutions. And then, no joke, are you going to be sick of this? We're going to do 2 straight days of graphing, substitution, elimination. Graphing, substitution, elimination. That's Friday and Monday. There is no reason you can't pass this test. No reason whatsoever. Remember, on the test, there's going to be a graphing calculator portion. So I'm going to have you do the written one first. When you finish that, you're going to come up to me, hand me your test, and I will hand you the graphing calculator portion. It'll only be 4 questions. I don't need to do 20 of these. And you'll solve a system of equation using your graphing calculator. All right. Homework tonight. I saw. It was very beautiful. No, I left it on our desk. All right. These are not the hard or challenging elimination ones. There is going to be an extra step involved, but these are actually just as easy as they were yesterday for those that actually attempted to do your homework. Okay. You will find out that these are just as easy. It does require you to do 1 extra step, but that step is pretty easy. All right. The way you get good at this is that you pay attention in class. You actually do the examples. Like, you don't watch me do the problems that I say, hey, let's do this together. You actually attempt it. You find out you got it, you don't got it. Okay. When I say watch me do one, I do mean that. But I'm saying when we get to the ones where we got the blue squares, the green squares, you're doing the problem. I gave 5, so you should have one.
No, I'm saying, what do you want me to do?
Oh, thank you.
Are we still just adding and subtracting?
Never heard that before?
No.
You're turning it up.
No. Whenever you have your music played too loud, your parents come in and they say, turn that racket down, and you say,
Ruckus.
if it's too loud, you're too old.
Whenever in my car, my mom says turn it down, I can't see.
That's good.
Whenever my dad tells me to turn it down, I'm like, how? You can barely get TV to that.
All right, here we go. So this is part 2. It will introduce a new thing, and it answers that question that we left off with yesterday. We'll get to that here in a second. The basic idea for elimination is I give you 2 equations and you stack them. You decide whether to add or subtract. You do that. It gets rid of, it eliminates one of the variables. You solve for that variable that's left. You take that answer, you throw it back into either one of the original 2 equations, and you get to the second variable. You write your answer as an ordered pair because big picture, we're finding out where 2 lines intersect. Yesterday and last night for homework, you had no infinite solution, no solutions. Tonight you will, and that's not the new thing, okay? All right, but we will talk about that. But remember, the final answer is x comma y, or no solution, infinite solutions. Okay, so we stack the equations. Remember, Kaylee, what's the rule? We subtract, right? Which means we switch the signs and then we add. So are we adding or subtracting here? You got it now. So we're going to subtract. That means you go to the second equation, swap all the signs. Positives become negative. Negatives become positives. And then you add. We get to that one answer. We toss it into one of the 2. We get to the second answer. You write the answer in the form of x comma y. Done. Great. The rules are 8 and what?
That, right there.
Say.
Stack the equation.
All right, I'm going to stack these 2 equations. I take those 2 equations. You see them?
Add or subtract.
Rylan? Everybody watching?
Yeah, stack.
Aiden said stack them. We stack them. Now what, Aiden?
Now add or subtract, so we're gonna,
We got a problem.
yeah.
What's the problem, Aiden?
The bottom one we need to change subtract.
The problem is not the bottom one. Rowan, what's the problem here?
The top one.
Nope, that's not the problem. What's the problem, Tristan?
None of the numbers match.
None of the numbers match. Look, here's my x. I got a 2 and a 7. Technically, it's -2, +7. Look at the y's. I got a 15 and a -5. None of the numbers match. Yesterday, I said stack them, and then you determine whether to add or subtract by the numbers that match. Nothing matches. So we can't use elimination.
So what do we do?
Except we can if we know one trick. That's what today's class about, is this trick. By the way, most of the time, the numbers won't match. That's crazy to think that the numbers will match. That only happens rarely. Most of the time, it's like this. The numbers don't match. So here's the trick. We need a new technique, and it's not that new. It's just one extra step. So think about this. Is this true? Okay. It turns out in algebra, you can do, if you have an equation, you can do anything you want. Literally anything, as long as,
You do it to both sides.
well, let's multiply everything by 2. What do you get?
8 plus 2.
So you are allowed to multiply or divide by anything you want, positive or negative, as long as you do it not to both sides, but to everything that is both sides. You are allowed to multiply. You will still wind up with a true equation. That's the trick we're going to use. For the ones where the numbers don't match, we can use this technique. It's called scalar. You're scaling something up or down. Dividing would be going in the downward direction. You can multiply or divide the whole thing by any number you want. That's how we'll match numbers. Okay? I can multiply by a negative. I still get, if you multiply through by -3, I still get a true equation. This is the trick that gets rid of that problem. Hey, the numbers don't match. Hey, the numbers don't match. Well, let's make a match. You got a choice. You can either match the x's or the y's. Pick one, Aiden.
The y's.
Let's match the y's. Hey, that's a 15. Could I turn -5 into a 15? By multiplying by 3 or -3, your choice. Hey, what's the easiest choice? Do we want the numbers to be exact, or we want one to be negative, one to be positive?
Oh,
We want that, because remember, if they're opposite signs, we're adding. If they're not, then we got to change all the signs. So let's save ourselves some work. Let's multiply through so that we get the opposite of 15. Therefore, I'm going to multiply by a 3. Now, if I multiply by -3, certainly works, but then I have to subtract. Everybody with me? So I'm going to multiply not both equations, this equation, everything by 3. Right? I'm going to match the y coefficient. So I'm going to multiply everything by 3. That's now going to be,
like 21.
that's going to be,
50. Negative.
and that's going to be, uh-oh, who can do that in their heads?
61.
51 or 61?
I think it's 60.
51. Okay. All I did was take the bottom equation and multiply everything by 3. Why? Look, I got matching numbers and they're opposite. We like opposite because that means now we add. All right, there's your extra step. That's it. Class dismissed.
Oh,
All right.
let's go. We're done.
All right. So let's add. What do we get? Add. 19, nothing. We'll get there.
A lot.
What added to 32 is 51.
19. Oh, yeah.
Therefore, x equals
19.
what?
$19 Fortnite card.
X equals 1. Stay with me, please. Does everybody understand what I just did?
Yeah.
Our problem was that we had an equation where things didn't match. You pick one. Any one works. Why didn't we pick x?
Because that doesn't work.
We would have to multiply both equations by something. That's too much work. However, I can match the y's easier. So there is a little thought process. Pick the one that requires you to, we can match the x's. Let's see, how can we make both of these the same numbers? Multiply the top by, and then the bottom by 2. And then I get a 14. We could do that. That's just more work. Why do more work? We can match the y's here. So I multiply everything in the bottom equation by 3 so I could match the y's. Because when you did that, we got 15y, negative 15 on the bottom, positive. We add. We like adding. We get that, and we just simply solve that equation. We got 1. We take this 1, we go back to either equation. I'm going to use the bottom one. It's got fewer negatives. Okay. I use the bottom one. Actually, no, I use the top one. I'm not sure why I chose the top there. Whatever. Let x be 1. That's going to give me a -2. Add 2 to both sides. That gives me a -30. And 15 into -30 is -2. Did I go too fast on that?
19.
This is the same thing you did last night for homework, those of you that did it. These are the same thing that you did last night for homework with that one extra step, scalar multiplication. By the way, that's it. That's the whole class right there, other than infinite solutions, no solutions. Ryland, please do this when we do this, okay? Ryland, do you want to match your x's or your y's? Which one's easiest? Yeah, because we would have to multiply, maybe get to 15, the top by 3, the bottom by 5 to match the x's. But over here, I could just multiply the top by a 3, and we would get -6, +6. You see that? So there's some thought process here. You can match any variable you want. Go with the easiest one. Okay, so we're going to multiply just the top by 3. Can anybody do that in their head real quick? And if there's a mistake to make, it's what I just asked you to do. Do it in your head. And then I'll have a kid, they're like, yeah, I can do this in my head. And then they'll mess it up. You are doing 3 multiplications there. So it might not hurt to actually draw the multiply by 3. Some kids I can't ever convince that. Other kids I can convince. That's not that much work to put 2 parentheses in a 3 and then write your answer. But you are right, -15, -6y, and a 12. I will also see kids make it all the way through this part and forget you also got to multiply the 4 times 3. Is anybody lost in what I just did? Ryland said, let's match the y's. We like one when one's negative and one is positive. It doesn't have to be. If you get the same number, well, then you got to subtract and change all the signs on the bottom one. You can still do that. We add, that's going to give me -12x That goes away, and that's going to give me an 18. Oh, ugly one. Ugly answer. We're going to get 18 over negative 12. That reduces by 6 to what? Negative 3 over 2? Everybody see that? That reduces to negative 3 over 2. And that's what I got to toss into one of these. Ugh. Hate fractions.
That's great. That's great.
I'm going to use this one because everything's positive. We throw negative 3 over 2 in for x. Notice nothing cancels here. We get negative 9 over 2. This is as ugly as it gets. The fractions are still there. By the way, if you wanted to clear the fraction, you could. If you're okay with dealing with fractions, then deal with fractions. Who wants to clear the fraction? Who wants to just deal with it? Clear the fraction or deal with it?
Clear the fraction.
All right, what are we going to multiply everything by?
2.
Let's multiply everything by 2. If we multiply this thing times 2, well, the 2's cancel and you're left with negative 9. We multiply that by 2 and we get 2.
2.
We get 12y. When we multiply 6, we get 12. Okay, fraction's cleared. Now we can solve it. Add 9 to both sides. We get 12y is equal to 21. It is negative 9, but then we would add 9 to both sides. Okay? And that's going to give me what? 21 over 12 is the answer. What? 3 goes into both of those? So 3 goes into 21 7 times. 3 goes into 12 4. We get 7 fourths. Oh, wow. That's just too much work. So xy, so negative 3 over 2, 7 fourths. I don't think I cleared the fraction. I think I just dealt with the fraction. Yeah, I just dealt with the fraction. We do get 7 fourths, though. So negative 3 over 2, comma 7 fourths. Are the eyes rolling back in your head, or are we okay? Okay. All right. I said, now we're going to grab our pencils. We're going to do this. Like, no joke. Let's do this. Let's make sure you got this. Piper, you want to match the X's or you want to match the Y's? It's your choice. She said, let's match Y's. By the way, this one, either one is fine because we just need to multiply. We match the X's, we multiply this one by 4. We match the Y's, what do we got to multiply the bottom by? How do we turn this into a 5y? Multiply by, how about by 5? 5 times 1 is 5. So we're going to take the bottom one. Did I do it by 5? Let's see. No, I didn't. I did the X's. Okay, so we're going to do Piper's suggestion. We're going to multiply the bottom times 5. That'll match the Y's. It's the same amount of work for this one, X's or Y's. So to do that, well, I rewrite the first one. So that's 8x minus 5y is equal to 7. The second one, we're going to multiply everything by 5. Row and do it real quick.
40x.
Whoa. Bottom one.
Oh, see my B. Negative 10x plus 5y equals negative 15.
Perfect. Now we can add. Hey, look, we made one negative, one positive. That's perfect. Rylan, you done? The whole problem? I'm serious. You get nothing out of it if all you ever did was watch it. I can watch this and say to myself, like I remember having this class and say, yeah, that looks easy. If you don't actually do it, you don't get the practice. You got to do this. Landon, you're next for that speech. All right, 8x and a negative 10x gives me negative 2x. The y's go away. 7 minus 15 is negative 8. We okay? Porter, we good? Well, I can do that in my head. X is equal to 4. Negative divided by negative positive. We okay with 4? All right, Rylan, you pick which one, first or second one? Yeah, let's do the first one. So we're going to let x be 4. So that's 8 times 4 minus 5y, and that equals positive 7. Well, that's a 32. Minus 5y is equal to 7. Subtract 32 from both sides. See, 32 or 7 minus 32.
Negative.
It is negative 20. 32 minus 7. Say it.
Negative 25.
Negative 25. So we get negative 5y is equal to negative 25. Therefore, y is equal to it's 5. Remember, we're solving for y, so get rid of 32 first. We're solving for y. You could add 5y to both sides if you want to deal with positive numbers. It wouldn't be wrong, it'd just be extra work. Look, the equation only has one letter in it, yes? So let's get rid of the 32 first, subtract 32 from both sides. X, Y, so therefore we got 4, 5 as your final answer. Boom. When I did it, I picked let's solve for X and just, we good? When I did it, I picked to solve for X, and you'll see that we'll get exactly the same answer. We match the X's, then I'd have to make that a negative 8, so I'm multiplying everything by positive 4. And we still get 5 for Y. Toss that in, and we still get 4 for X. So we get exactly the same answer, whether you match the X's or the Y's. But absolutely, give it a good 10 seconds to make a good choice. Whichever one you think is easy. Hey, there's no back. How many of these are there?
5.
There's 6 of them, right? Let's do them all. Okay, now there's 5 left. Aiden can count. Good job. All right. Harley, you want to match X's or Y's on this one? Agreed. Notice, we could match the X's, but we would have to turn this into what's common? 24, is that right? We'd have to turn them both into a 24. Okay. Heck that. Let's just match the Y. So what are we going to multiply the bottom one by, Harley? Positive 3. Does everyone see that? We're going to multiply the bottom equation by positive 3. Nathan, thumbs up. Okay. So we're going to multiply the bottom one times 3. That's a 24x. Positive 3y. Negative 6. You're supposed to stop me if you're lost. You're not tracking. Hey, the y's match. Let's add. 24 minus 6, that's an 18x. Negative 12 minus 6, same signs, means add, so that's negative 18. Oh boy, math teacher wrote this problem. Look at that, right? In real life, that doesn't happen. These are like 37 and 26 or something, right? When a math teacher writes out, boy, we like 1 to be the answer, negative 1 to be the answer. So x equals negative 1. Everybody okay with that? We take negative 1. Which one do we want to use, top or bottom? Bottom. Hey, I used the top. Look at that. Maybe, I don't know, 24 is too big, but we're multiplying by negative 1. It wouldn't have been that big of a deal.
Maybe because all negatives cancel.
Yeah, but the only one of them will cancel when I do that time. If I were multiplying everything by negative 1, I agree, but I didn't really get rid of all the negatives here. I got rid of one of them. Subtract 6 from both sides, we get negative 18. Divide by negative 3, and we get positive 6. So we get negative 1, 6. Hey, do you remember where we started? Solve by graphing. I gave you this as one of the problems. This required you to solve for y. That was a pain in the butt. Now you didn't have to do that, but you still got to the answer. Yeah. I did. And here's what happens as we get higher level math. It's not skipping steps. It's just that we know what happens. I mean, I don't put divide both sides by negative 3 anymore because it's, I don't know, by the time you get to 9th grade, you've probably done this, I'm not lying, 500 times. Solving equations easily. You do it in 7th grade, you do it in 8th grade, now you're doing it in 9th grade, you'll be solving equations next year in geometry. We just tend to not write the steps because we all know what you're supposed to do. It's not that you're skipping a step, it's just that we all know, hey, I'm supposed to subtract 6 from both sides. You can still write that if it helps you, but most of us kind of skip that part. Notice I didn't really skip a step. All I did was not show the work. All right, one more, or are we ready to move on? You can. I got rid of it, so it's not there anymore. You could use any one of the three equations. The first one, the original second one, or this one, and you will always get the right answer. That's a good point. I didn't make that. Any one of the three equations you could have used. All right, I'm going to skip box 3. We're going to get to the more challenging. It's not really more challenging. Anybody actually do it? It's 2 comma negative 5. All right, I'm going to skip that one and box 4, and we're going to move on to the second to last thing of the day. All right, the big but here is this. Hey, what are we matching? X's or Y's, Aiden?
Why?
You just picked the thing off the top of your head.
Yeah, I just want to match Y's.
What's the problem with this one?
Yeah, they're gonna be bad either way.
It's going to be bad either way. So you will eventually, this is the real power of elimination. You will eventually get to where there's no easy way of matching numbers. So these right here will require you to, I'm going to agree with Aiden. You basically pick a letter and you stick with it.
Well,
Okay?
why is so much easier? That's 6.
Yeah, but this is 12. So if you think ahead, maybe you want to deal with a smaller number. I'll agree with that. But the point being is that, well, you're going to be doing both equations by number. I also want you to make your life slightly easier. Yeah, we want to match something, but we would like one to be negative and one to be positive. So that when you decide what to multiply, in this case, both equations, do that thinking ahead. So Riley, what are we matching? He wants to match the y, so he's going to turn these both into 6. But I want one to be negative and one to be positive. So which one? And it doesn't really make a difference. Which one you want to be negative, which one you want to be positive? So the first or second equation to be negative.
Oh,
So he wants to make the first one to be a negative 6 right here. So what will we have to multiply by? So we're going to multiply the first one by negative 3 because he decided to make that negative 6, which means we need to make this a positive 6. So we're going to multiply this equation by
2.
Here we go. Now everyone stop what you're doing and look at the board and make sure you understand everything we just did right there. We first determine what are we matching, X's or Y's. It really is your choice when they're not friendly like this one. Once you make that choice, though, I want you to make one negative and one positive. It doesn't matter which one. You want the bottom one to be negative, the top one positive, that's fine too. Okay? Once that's done, then you write what you're multiplying by, and then you do that math. All right, whole thing, Rylan, top one. How about minus 6y? Second one?
8x plus 6y equals negative 6.
Negative. Okay. Pointing out the obvious. If you do the math wrong, it's not going to work. In the sense of you're not going to get what the true answer is. Is it going to work to get you to an answer? It certainly will. Boy, will it really go bad and it will get really ugly numbers. And you won't even know that you got it wrong because you won't notice you made a mistake. So take your time, try not to make a mistake. Add negative x. That goes away. Over here we get,
Negative.
therefore x equals, how'd I get that, Ron? Yep. Yeah, but how did negative x equals negative 7 turn into x equals 7?
Because you cancel out the 2 negatives.
I either multiply both sides by negative 1 or divide by negative 1. Either one's fine. Okay. Which equation are we going back to? This one?
Yeah.
Okay. So I'm going to take that, throw it into that one. Hey, Kaylee said that we could have 4 options here. This one, this one, this one, or this one. Got lots of options here.
I want the top one.
All right, we'll go to the top one. So we're letting x be 7. So that would be what? 3 times 7. Most people will do that in their head. Plus 2y is equal to 1. So we get 21 plus 2y is equal to 1. Keep talking.
Oh, subtract 21 by everything. And now divide 2 by 20.
Yes.
Equal 10.
-20.
Yeah, subtract negative 21 and a positive one that gives you negative 20. Therefore, round y is equal to
Is equal to 10.
is equal to.
Negative 10.
Therefore, the final answer is
X, I'm at 7, negative 10.
7, negative 10. All right, for my online e-learners, because I didn't make this, he made a different choice than I made. I said, let's match the y's. But I made the bottom negative and the top positive. It's the same thing, okay? So I'm going to multiply the top by positive 3. You multiply by negative 3. I'm going to multiply the bottom by negative 2. You multiply by positive 2. Okay?
Mr. C,
Yes.
does it matter which one you multiply by? Whether or not it's the top or the bottom?
It only thing that matters is we're trying to match y's or x's. So it
Okay.
doesn't matter if you wanted to multiply the top by negative 3 and the bottom by positive 2, or vice versa. Now, what
Okay.
would matter is I can't multiply the bottom by a 3 or a negative 3, the top by a 2 or negative 2. Because remember, that wouldn't match the y's. I
Yeah.
chose 3 for the top, 2 for the bottom, so I could get a 6y. And then I made one of them negative so I could have offsetting numbers. Okay?
That
On that
makes
step, then we simply add. That was pretty easy. One step, you're at the answer. Notice ours, because ours were opposite, we got negative x equals negative 7, and then we finally got to, mine didn't work out that way. Mine was, boom, there's the answer right from the start. Toss that back into either equation. I'm probably going to pick the top one. I did. Throw that. Now notice, this isn't the same one that you chose, but we will still get the same answer. Subtract 63 from both sides, we get negative 60. We still get a negative 10.
My choice was better, easier math.
For this last step, I agree. Okay. Notice mine was a better choice for this step, though, because you got negative x equals negative 7. You had an extra step. Okay, but yours for that one gave you a smaller number to work with. Okay, cool. That's as complicated. This one right here is complicated as it gets. Okay, no more complicated. The other nice thing about this is it's still elimination. I mean, the basis of elimination each and every time. Once you get past the matching the numbers, it's just straight up elimination. Kaylee? Say that one more time. Well, the reason why both of these were in parentheses is because there was no way of matching the x's or the y's by just multiplying one equation by one number. Notice, this was a 3 and a 4. There's no way you could turn a 3 into a 4 with one number. There's no way to turn a 2 into 3 or vice versa with one number. Mathematicians will scream at that answer, but I'm trying to give you the easiest answer. There is a way, but it's multiplying with an ugly fraction. And who wants to multiply by fractions? You can turn a 3 into a 4 multiplying with a fraction. But nobody wants to do that. Well, how do you turn a 3 into a 4? In other words, what times 3 is equal to 4? Multiply it times 3/4. We take 3 and we multiply it by, 4/3. 4/3. I got that backwards. Multiply 3 times 4/3. 3's cancel and you're left with 4. But who wants to multiply everything by 4/3? Ugh. All right. We got 10 minutes left of class. We can do 2 of these, right? We have how many left?
1.
Well, then I guess we're only doing 1. All right. So the very last thing of the class is the thing that we haven't talked about, but we kind of already got an idea of how to do it. And that's infinite solutions, no solutions. Infinite solutions, no solutions. So let me get to that. Infinite solutions, no solutions. So remember, visually, this is what it looks like. One solution's great. They intersect, and that's what we just did for every one that we've done so far, right? We get a point. Infinite solution means that it's the same line. No solution means the 2 lines are parallel. So what will that look like for this elimination? Well, you're going to have 2 equations. If you're really on the ball, you can look at it and say what? If you're really on the ball, are those the same or are those different? Like I said, you're going to do about 5 of these where they're not the same, and then I'll throw one where they are the same. You won't even notice it. Just be ready for that. But if you're really on the ball, you're like, wait, this is just multiplied by 2. You probably aren't going to notice that until you actually do the math. So if you didn't notice it and you do the math, well, what are we going to match, x's or y's? X's, either one's fine.
X's
Okay.
Why?
All right. So let's match the x's. What are we multiplying by?
by 2.
So we multiply everything by 2. Remember, I want one to be negative, one to be positive. So I'm not going to multiply by 2. I'm multiplying by negative 2. So we multiply by negative 2. We add. What happens?
It's the same. But
Literally everything goes away, and what are you left with?
0. Big
0 equals, well, is that true or false?
True.
Infinite solutions. And then here's where you feel like a big dummy when you get 0. You're like, oh, why didn't I notice that? You won't, probably.
Bet.
Well, I'm just saying, when I give you, how many did I give you tonight for homework? 12 of them? Something like that? You're not going to notice it because you're going to get all these ones where there is an answer. And then you're like, oh, when is this homework going to end? And then oh, wait, 0 equals 0. Okay, infinite solutions. This one you won't notice, the ones that are parallel. Okay, you won't even notice it that it's parallel from the start. Okay, so here we go. What are we going to match, y's or x's?
X's.
Y's.
Okay, so what are we going to multiply the bottom by?
2.
Not 2. We're going to multiply the top by negative 2. Did I match the y's? Yes, good. So I'm going to multiply the top by negative 2. Can everybody see that? So I'm going to multiply the top by negative 2. That's going to give me 4x minus 2y
Negative 14.
negative 14. When we add them, once again, everything goes away on the left side. That's a 0. That's a 0. That's not a 0. It's negative 16. And you're left with this.
I mean, you can notice if you do like one little step.
As soon as you do that one little step, you will notice it. So did you have to actually add them? No, right? Therefore, what's the answer?
Parallel lines. Infinite.
By the way,
None.
no solutions.
Zero
Remember,
slash.
do they intersect? Well, they're parallel. They don't intersect, so no solutions. Okay,
0 slash.
Aiden. Hey, where should your attention be? Okay. Was it? Okay. That's it. All right. In the remaining 5 minutes, I want the books open. I want you to get started. You can at least get one done in homework so that you can all by yourself feel confident that you can do your homework without me there.
Okay.
All right. So open up your books, get started. Homework. For those of you that don't get started, you're going to remain to be for lunch. Yes.
Will we stay here for lunch anyway?
No, we're going to a different place.
Huh?
We will be going to a different place.
Oh, do we have to go? Could we go to teacher's lounge?
No, you're not allowed into the zone of no student.
I went in there before. There's 2 third grades.
Yeah, and like a million things. I think there's only one thing.
I thought that was a good. I thought that was a good.
Oh, you My mom works at My mom works at like 4 schools.
Wait. Your mom's still there.
That was
She's really just here.
It turns out that's
Yeah, and it's different colors.
Feel the whole team freaking out in like 4 seconds.
Look at I got to do that.
And that's the one that's scary.
It says 1 through 9.
Right?
It says 1 through 9 solver system.
So look, she just pointed out solve the system. So basically 1 through 9 is solving.
It says on number.
So look at what's 1
Everybody understand the oral exercise, written exercise, a little trick there for 2 through 8?
No.
It says on number 2, go to the oral exercise and do number 2. For number 4, go to the oral exercise, do number 4.
Ready.
Come on, Porter, get your stuff out. Get working. Haley, questions?
Yes, I'm confused on how to do number 2.
All right. Let me see. How can I help you online? Let me get a white sheet of paper here and I'll give you help.
I don't have a math book.
Share.
Who has their math book?
Hey, yo, I got you.
Nobody has their math book.
Oh, plenty of people have a math book. All right, Haley, you looking at a white sheet of paper?
Yes.
All right, give me the problem.
3a plus 5b equals 3.
What do you do for math?
Equals what?
3.
Okay, and the second one?
A plus 2b equals 13.
So which is the easiest one to match, the A's or the B?
A,
I agree. A plus 2B equals what?
13.
Okay, so we're gonna match the A's. So this one already says 3A, so what are we gonna multiply the bottom by?
3.
And I want one to be positive, one to be negative, so I'm gonna multiply not by 3, but by -3. Do you understand why we want one to be positive, one to be negative?
So that way it cancels out.
Yeah. Okay, so I'm gonna rewrite the first equation. That's 3A plus 5B equals 3. And then the second one, I'm gonna do that math there to the left. So do that math for me in your head real quick. This times this, this times this, this times this. I'm doing it on the board right now. Haley?
Negative 3a plus negative 6b equals
Oops. 13 times -3,
10.
negative 39.
6.
9.
Yeah.
Yes?
Yes.
Now, we designed that, so now all we have to do is add.
Okay. The a's cancel.
Yep.
Then you're left with negative 1b
Equals negative.
negative 36.
You got it. Therefore, B is equal to 36. Now we take that answer, Haley, and do what with it?
We do
I
that times the top.
Agreed.
Okay.
Do that times the top. Let B be 36, going to be a big number. So we get 3A. 5 times 36 is 8, 15, 180. Plus 180
No, he said she was gonna take whoever didn't finish their work.
is equal, no, I said anyone who didn't work. Is equal to 3. Can you solve that one for A, Haley?
What do you mean by that? I'm confused.
I mean, could you take it from there to get what A is equal to? Subtract 180 from both sides, so we get 3A is equal to, I'm subtracting 180, so we get negative 177. And then I sure hope that's divisible by 3, 177. Let's see, 7 plus 8, 1 is 8, 8 plus 7 is 15. It is divisible by 3. So A is going to be equal to whatever that divided by 3 is, negative 59. And your final answer is to take what's in the box here and to go write it as A comma B. So your final answer is 36 comma negative 59. And once again, the power of this is that you wouldn't have been able to graph this on a normal graph that only went to 10 by hand. You could do that on a graphing calculator, but not by hand.
No.
All right, that's how you do this.
Okay, that answered my question. Thank you.
Cool. You have a wonderful day.
You too.
Thank you.